Ever get that feeling? Like the really big stuff, the breakthroughs that change everything, they're kind of bubbling away just out of sight.
You mean like they're under the radar?
Yeah, exactly. And then bam, they explode onto the scene.
Ugh.
That's the vibe I'm getting with AI and quantum computing. It's like this quiet revolution about to go supernova.
I can see that.
And you know me, I'm all about getting ahead of the curve. That's why we do these deep dives, right?
Mhm.
So today, we're diving in before this hits the mainstream, before everyone's talking about it.
That's good to me.
We've got this article, How AI is Transforming Quantum Computing, and let me tell you, it's packed with insights.
All right, so where do we start?
Well, by the end of this, you'll understand why everyone's so hyped about quantum computing, but also, why it hasn't quite lived up to the hype yet.
The potential versus the reality.
Exactly. Then, we'll see how AI is coming in to solve a massive problem in the field. This is where it gets really interesting.
I'm intrigued already.
And then, get this, we'll even touch on how this could, rewrite our understanding of physics. That's right, physics. Mind-blowing stuff.
You've certainly got my attention.
So, let's start with the basics. Quantum computing.
Yeah.
Why is everyone so excited about it? It feels like we've been hearing about it forever, like it's always just around the corner, promising to revolutionize everything.
Well, the potential is huge. I mean, think about drug discovery, for example.
Okay, yeah.
To design a new drug, you need to simulate all these complex interactions between molecules.
Right.
With classical computers, that takes forever. It's like looking for a needle in a haystack, one piece of hay at a time.
So quantum computers can speed that up.
Dramatically, because they work in a totally different way. See, classical computers use bits, which are either 0 or 1. Quantum computers use qubits, and qubits can be in multiple states at the same time.
Whoa, okay.
It's like this crazy parallelism that lets them tackle those complex calculations way, way faster. Imagine analyzing the whole haystack at once. That's the power of quantum computing.
So drug discovery, that's one thing. What else could quantum computing revolutionize?
Oh, so many things. Optimizing financial markets, creating super secure encryption, modeling climate change with incredible accuracy. I mean, we're talking about problems that are just impossible for even the most powerful classical computers.
That sounds amazing. But the article also mentions a big problem. Something about errors.
Ah, yes. That's the catch. Quantum computers are incredibly sensitive to their environment. Like, even tiny changes in temperature or magnetic fields can mess up the qubits and cause errors in the calculations.
So how do we fix that? Is that where AI comes in?
Exactly. AI is becoming really good at spotting, predicting, and even correcting these errors. It's like having an AI guardian angel for your quantum computer, always watching over it, keeping things running smoothly.
Okay, that makes sense. Any real-world examples of this AI in action?
Oh, absolutely. Google AI created this thing called AlphaQubit.
AlphaQubit, right.
And they trained it on data from their Sycamore quantum chip. Remember that one? Made big news a few years ago for achieving quantum supremacy.
Yeah, I remember.
So AlphaQubit learned to recognize and fix errors so much better than traditional algorithms. It really boosted the performance of that chip.
Wow. So AI is basically making quantum computers much more reliable.
That's the idea.
But wait, the article mentions something else too, something called atoms and tweezers. What in the world is that?
That's another super exciting area where AI is playing a key role. Atoms and tweezers, also called neutral atom arrays, is all about trapping individual atoms using electromagnetic fields.
Like actually holding an atom with tweezers.
Well, not literally, but you get the idea. It's like microscopic tweezers. And then they use lasers to manipulate the atom's quantum state. It's pretty wild.
Sounds super delicate. Why go to all that trouble?
It's all about scalability. Atoms are tiny, so you can pack a lot of them, a lot of qubits, into a small space.
Okay.
Plus, these trapped atoms are less affected by all that environmental noise we talked about. They're just naturally more stable.
So it's like building a more robust quantum computer from the ground up.
Exactly. And AI is crucial here. It helps position those atoms just right, making sure they're arranged in a perfect array so the computer works at its best.
I'm starting to see how this all fits together.
There was actually a recent experiment. They managed to assemble over 2,000 atoms in a near-perfect array. It's a huge step forward.
That's incredible. But the article goes even further. It hints at the idea that AI could, rewrite physics. How is that even possible?
All right, so this is where it gets really mind-blowing. It comes down to the very heart of quantum mechanics. The theory, as we know it, says there's a fundamental randomness to how particles behave.
Right.
But what if that randomness isn't actually random?
What do you mean?
Imagine AI could consistently get rid of those errors in quantum computers beyond what we thought was possible, beyond what we thought the randomness principle allowed.
So there's a pattern we just haven't been able to see.
It's a crazy thought, right? But if AI helps us crack this, it would completely change how we understand physics. It would impact every area of science.
Wow, that's a lot to think about.
Right?
This deep dive is living up to its name. It sounds like atoms and tweezers plus AI could actually make commercially viable quantum computers a reality sooner than we expected.
Absolutely. And the article is right. Everyone needs to learn more about AI and quantum computing. It's going to change everything.
So, if this quiet revolution is about to erupt, what should our listeners be thinking about right now?
If AI can find hidden patterns in what we thought was random, what other givens in science might we need to rethink? What other mysteries are waiting to be uncovered?
That's a question I'll be pondering for a while. We've only just scratched the surface here, but hopefully this gives you a head start. You'll be able to say, I knew about that back when.
Exactly.
And who knows, maybe you'll be the one to make the next big breakthrough.
You never know.